Hello reviewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about top human stupidity. So let's dive deep into it. So first stupidity is dams. Now let this be very clear. Dams are natural. Sometimes they are found by natural events and sometimes they are animal made. Like beavers are very well known in Northern American continent because again, it has the power to take a river and make it into wetlands, which is a good thing. Which again, for those continent, it kind of is very important given the fact that they have forest fire, which are brutal and bad and roast way too much places. So beavers are like almost a natural counterdoor to it. So dams are here. Dams are natural. That's good. Only issue is that we humans kind of made it mega, and mega equals death. What does that mean? Think in this way. Let's say you're donating blood. Little bit of blood is not going to harm you. But if you donate 6 or 7 liters of blood, it's like, yeah, bro, no. So that's the same thing happened. Dams, again, we have been doing it for centuries. But again, we did not have the technology to truly make them massive. So we were kind of safe. We are playing in the small leagues, no big issue. But once we started to reach mega dam category, meaning the megawatt rating out of it starts to become huge, like 500 megawatts, 600 megawatts, 12,000 megawatts, three gorgeous dam. So once we started to reach that point, then it triggered the death. Basically, it's like you're giving up too much. Now, that itself is so bad. It's like we, in our short-sightedness, think that we build a dam, we save water. What actually happens is like you build a dam, you terminate the whole river because again, it becomes the salt level becomes unbalanced because it's natural. It's supposed to get the freshest water from rain or glaciers, and then it slowly starts to pick up sediments and it slowly starts to become salty, and then it goes into the ocean. Neutral, everything is, and across the river, especially a long river, you will have different marine life adjusted to different salinity. Once you wabam it, it's almost like you are drink water, you pee, right? It's a normal thing. You drink water, you pee. That's what the river is. It has to do that. The moment we stop it, we think we have protected ourselves. No, all you did is cooked that river away. So how does that happen? Again, you increase the surface area of the river exponentially. The evaporation rate goes up exponentially. And here's the deal. Whenever a dam is built, there are people known as hydrologists whose job it is to calculate how much loss, how much evaporation is going to be extended. Basically, there is a natural evaporation, right? If you have a river, it's exposed to the wind, it's exposed to the sun. So there is a X amount of energy, that's X amount of water that's being lost. That's normal. How much more it becomes? Now, original calculations were like, 15x, 16x. And best guess was like, again, this is around 90s. People were like, yeah, it will roast the river in 30 years. But who gives a damn about 30 years? It's not like we live 90 years, so nobody cares. So we did that, and here's the deal. Global warming happened. Global warming entered the scene. So all the calculations that were like, in 30 years it's gonna roast the river, again, that means there is that calculation for Three Gorges Dam, and more than enough hydrologists were protesting because they knew the size of it was so huge, it will cook the river instantaneously. And be mindful, the river that we are talking about, it's an ancient river, meaning for thousands of years, the sedimental data and their own recorded history, again, depend how much you want to trust it, but the fact is it never dried out. Rivers do not dry out. That's not logical for rivers. Again, some rivers in some extreme scenarios will go from rain swelling up to summer drying out. Most river, all it does is like rain swells up and during summer it shrinks, but it never goes zero. Rivers are what we call permanent water features unless humans are there. When we build dam, we increase the surface area exponentially, water evaporates exponentially faster, you have sedimented determination, so your salinity is messed up, and the downstream, because you choked flow, now all that water boils off because again, surface area is too much now, because again, water level has dropped. So consequence, both sides water loss becomes exponentially higher. And again, China started to smoke too much weed, and they were like, we're going to build a dam. Again, every hydrologist screamed, you cannot build a dam every 100 kilometers on a river. You're not going to have a river at the other end. But they still did. Again, dictatorship and logic. And they did it. And now they no longer have water. And be mindful, every year you must see they have extreme droughts. And every year they have extreme floods. That happens when you build too many dams on a tiny river. And power production is also very low, which again, I'm reasonably sure you must have known. Last year, say it was the whole news cycle. Oh, Elon factory was shut down because again, there was not enough hydropower. So it's one of those things, we thought it was a good thing, we built it and results are in, and it's like it was the worst dumb idea we could have done that. Instead of having a fresh water source, we boil it away. Again, evaporate it away, but the outcome is the same. Water turns into steam, we no longer get it. And you're like, wouldn't it rain? If you take, basically water, boil it away. Where does it rain? It's not guaranteed it's gonna rain exactly in the same place. It can rain on ocean. Most likely it's gonna rain in ocean. Why? 70% of Earth is covered by ocean. And the hotter the surface gets, the harder it becomes for rain to naturally occur. So over time, you end up like this. There is no rainwater cycle. This was a sea. Let that be very clear. This was a freaking sea, which Soviet Union boiled away. And yes, Soviet Union did that. Like, and again, how did they do that? Irrigation canals. And be mindful, this is another aspect which, again, I'm recently made aware of, is that we have irrigation canal. Again, India also has boatload of it. And it's our open canals. Now, again, in early days, I did not truly understand. I used to think like, oh, 100 degrees Celsius, only then water boils. No, evaporation can happen at any temperature, any temperature. As long as you have sunlight pouring onto it, photons will impart enough energy into some molecules that they will be at the surface. And if wind is there, there's just going to be heat out of there. So larger the surface area, larger the solar exposure, the more likely you're going to lose water. All the canals, they are losing so much water that you have to over flood them from the irrigation side. Basically, the dam's reservoir has to flood too much, then you will get some amount of water on the other end. Oh, and there is minor issue. That water is now slightly more saltier than it should have been. So if you ever worried how Egyptian cultures fall, like the original Egyptian culture, it's like, and there's like the salt, farming made everything salty. How? Water, open irrigation, little bit extra salt, little bit extra salt, little bit extra salt. So basically dams cannot go on, and if we have to use dams, at least we can do to make sure our existence is delayed a bit longer is make sure that all the open canals are turned into pipelines. There is no solution where we can just like, oh, let's just boil it away. It's like, yeah, that's not an option. So it was basically short-term gain and long-term loss, permanent loss, not even long-term, permanent loss. There are rivers in India that never used to dry. Like again, we grow around it. It's like, yeah, it's a river, it's a thing, it's here. Dam is built, it's gone. Now, first it will happen, oh, the flow is a bit less, 2-3 years later, it's like, okay, flow is really less. 5 years down the line, yeah, gone. In summer, it goes away. Then it will become like only once in a while when we have extreme rain, then it floods for a few days and then done. So this was very serious consequence. And why? Because it's the only source of permanent fresh water. We roasted it away. So that's not accepted. And be mindful, all the calculations are wrong because they were never ever done with exponential temperature increase that is happening due to global warming. The worst my school time was 35 degrees Celsius. Whoa! What is worse right now? 45 degrees Celsius. So all the calculations, lol. Again, we did this. This happened. This is from 2015. Sometimes it rains way too much. And again, if you watch this, be mindful, this is already pre-smalled one. The boundary that you see was the original sea boundary. Again, Soviet Union fried it away. So here's the, if we do not change, river's gonna go away. And with it, fresh water. And I never wondered, like, if we have so much canal, why the heck we are losing groundwater? Then it's like, you're not actually getting that much water. You think like a billion cubic meters sent, and it's like, yeah, 500 went out the other side. So dams were our first stupidity. We thought it was a good thing. We tried it. It's not. Now, like, what can we do for energy? We can do solar for energy. What can we do for flood control? We have a lot of options without building dams that can allow us to control floods. And it's like, what about 24/7 electricity? First, dams do not actually make that much power. And this is another reason why, even though India and China, they have so much dams, they still have water shortage, because dams require a certain level of water pressure, head pressure, in order to make enough energy. If they let it draw too much, again, you will still get the water, but dam will no longer work. The generators will not provide enough power. So that creates a scenario. It's like, yeah, it would have been better if we just had let the river run its course. You take a little bit out, again, water cycle remains normal. We do not excessively boil it away. We'll have at least something. So that's the whole point. If we do not change, we go away. And how can we solve the energy 24/7 problem? Here's the deal. Once you increase solar exponentially, you will have a surplus. Once you have the surplus, then engineering will come into it and we'll figure out how to store it. But you have to reach that point. And can we store that much energy? Absolutely, easily. Shut up, take money. It's just that it's not economically desirable as of now. Unless you have surplus, economics will not make sense. So we have to go through that route. Again, we tried dams. It does not work. It's bad for us. And again, proof is in the, try to find any lakes near you, you will know. So dams were our damn mistake. That was the first stupidity humanity did. Mega dams equals death. Then we come to farming. That as was water, this is food. Now, be mindful, food is a bit less of a harmful thing simply because we learned it recently. Dams were kind of like, again, given the fact that there are hydrologists whose sole job it is to tell you how much water loss is, and you can say, okay, their calculations were off, but again, global warming made them off. It's not like they were not doing due diligence. So I cannot, that part, like we were accepting it willingly. It's like, oh, we're going to build this mega dam and this river is going to go away in 30 years. It's like, bro, we live 90 years, 90, 90. 3 generations. Each generation is 30 years. It's like, just because in your generation there is still going to be some river does not mean you should piss on your next future. It's like, sir, we cannot do farming anymore because we do not have water. So then we come to the second of farming. Now farming has gone through exponential change in last 30 years. Why? Some new knowledge has come to our understanding, specifically mycelium network. Now why it's such a big deal? Well, before mycelium network's true understanding, we did not actually had true context, and you would see contradictory data points. For example, we'll say you'll have fungus attacks, whoosh, whole crop gone. You can have insects, whoosh, whole crops gone. But here's the deal. Why the heck that never happens to forest? There is nobody tending to a forest. How the heck forest self-maintains itself? And the answer was mycelium network. So meaning, if an insect goes, wabams a plant screams. As in, like, there is its chemical signature that is screaming. It screams out. So all the mycelium network that is interconnected tells other plants is like, this is under attack. Now increase your concentration of countermeasure. What countermeasure? Again, depending on what ant species is getting affected by, it will have a countermeasure for it. Yes, it actually makes chemical cocktails for countermeasures, depending on what is required. And the whole area becomes a cauterized wound. And the animal can, if it goes from like, okay, I eat this leaf, I jump into the next leaf, okay, it's extremely salty. Far saltier than I expected. Again, every plant has a tolerance to it. But if all the plants kept maximum tolerance, again, it will be bad for us also, and it's also bad for plants. So it's a poison that they are dealing with. So they're like, hey, let's keep it at low concentration. And mycelium network is the emergency flood system. It's like, okay, all of them gives your one, and the cauterized part gets extreme concentration. Again, we kind of figured it out in 80s, and that time assumption was like, it's almost like an equalizer. Basically, you have a lot of phosphor deposit here, a bit of calcium deposit here, and mycelium network just balances it out. Now, there is actual trading algorithm into it, meaning, now like, wait a minute, trading requires materials, right? Plus and minus material, yes? So, okay, all the underground thing, water, nutrition, these are mycelium's output. So what is they are buying for it, right? That's what they are selling. So what they are buying? Energy. What does mycelium network does not have? Photosynthesis. What does plant have surplus of? Photosynthesis. Equilibrium. Again, that's how, this is a very recent thing. And if you're like, hey, wait, it sounds like a Avatar movie, that's what it was inspired from. It's a real world thing. Very recent thing. So what does that mean? That simply means if we truly utilize its properties, we're going to have very efficient farming, meaning the amount of water needed to farm will go down, the amount of diesel needed to farm will go down, and it will become sustainable, meaning we'll not go the route of Egyptian where like everything is salt. So that's the awesome part. Not only it saves money, it also increases yields, it also makes everything far more resilient, robust. So what are the tools required for doing it? Cover crops, meaning this soil equal dead soil. How many of you have ever noticed this color soil in the natural forest? Answer would be zero. Never. Natural forest is always black soil. And again, even I did not know that. We used to use brown for that, and then we realized that's farming's side effect. You should never have this. That means carbon content on the soil is way too low. Plant is a carbon organism. It's a carbon-based life form. So it needs it. So what the idea is, whenever nature sees something like this, blank space, nature tries to fill it. It's almost like a healing algorithm. It's like, okay, let's flood this area. That's what we call, like, invasive plant species and all that. Basically, nature is trying to heal its wound, and we are taking it away. So all we have to do is like, hey, I'm not going to give you a wound. Meaning all nature wants is make sure that no ultraviolet falls onto the surface. And what nature I'm talking about is like an ecology at that area. So you plant your crops, and next to it, you plant a cover crop. Or even if you do not want to go this route is a bit extreme, a bit more advanced. You do need to know what you're doing. But if you're like, okay, I have cut all the crops are done, you plant something next to it. You never let the soil be naked for way too long, because the naked soil attracts life forms. You will basically fill up a place so other things cannot do. It's almost like how our gut bacteria is. So if you have a good gut biome, bad bacteria cannot just like, overwhelm anything. That's the whole thing here. Again, we did this last 10 years and results are magnificent, to say the least. So cover crops, now be mindful, it's not as easy as like old days. It actually requires calibration, like proper analysis. Thankfully, all governments that I have studied, be it American, be it Indian, be it Ukrainian, all governments are literally focusing, urging their citizenry, basically farming sector, to please use cover crops. All of them. India has what we call Krishi Vigyan Kendra. Basically, this is Department of Agriculture that is there for people's help. And because again, they have enough technicians there, they can actually study the soil, give you actual data. This sort of cover crops will work for you. Again, this is a hot temperature, this will work for you. You require like, let's say, and again, cover crops also makes the soil porous, meaning you can have whole ecology there efficiently. So cover crops, zero till farming. This is another thing. This is why farming degrades soil. Rather than enhancing it, it degrades it. Forest, as it gets older, it becomes far more enriched. Farming makes it de-rich. How the heck that's possible? Again, every time we go, vabam it exposes way too much area to sunlight. Not only it causes evaporation, it also cooks alive. Basically, you are sterilizing the ground. And again, it's our hubris where we used to think, oh no, everything has to be sterile. No, it needs a healthy mycelium network. Only then it can have a whole ecology that is needed underground in order to get for us to get the crops. So that's there. Another part is crop cycle. Now, thankfully, I could say that crop cycle was a very well-known thing. India specifically, went through what we call green revolution. So we had basically after independence, we were in a tough spot, so to say. So we went through green revolution and white revolution. White revolution was milk revolution. So we started to figure out industrialize the milk industry, and then we had turbocharged the crop industry in order to get enough yield where we can feed 1.5 billion people. And yes, we do feed 1.5 billion people because I'm pretty sure you know that people do not run on photosynthesis. So yes, Indians do have that kind of food, and yes, we do export it. Yes, we have bonkersly large amount of agriculture sector, even though on a smaller surface area. And yes, it's larger than China, even though China has 3 times the surface area. So yeah, we good. Like our green revolution did work, but be mindful that did come with a slight consequence. We messed up the crop cycle part. We basically started chasing profit rather than like, okay, let's give soil some time to equalize. So all these 3 things done correctly, basically you have to go away from horsepower model, basically more horsepower, you have to go to brain power. You have to study the soil. You have to figure out, it's like basically if the soil is compacted, all the cover crops you do is deep rooted cover crops. So it penetrates the soil. It allows the soils to become alive again, aerate again. Oh, and there is another benefit. What is the largest surface area on earth? It's agriculture land. If you use this sort of 3 tools, basically healthy soil, which is output of cover crops, zero till farming, and crop cycling, you have very, very spongy land. What does that mean? That simply means it's almost a pseudo wetland, meaning you can have brutal rains, and the healthy farmland would be like, I get this. It will drink it all. You will never even notice it. Oh, and evaporative loss will be also less. Why? You always have a cover. Never let sunlight touch the soil. There has to be a plant that is eating it. Soil should never be exposed like this. So we have to do this. Again, if we want to feed people, we do not want to roast our own future, we have to do this. And ironic part is we have adopted fiber and 5G much faster than, I'm not talking about Germany. Yes, there is a very famous German scientist who made a video right now. But in India, we got fiber and 5G very quickly, like boom. Heck, I have fiber. 300 Mbps. I can get more, like 1 Gbps, easy peasy. It's just that my pocket is not that deep and I don't require it. So 300 Mbps. I might even downgrade it. Like 300 is also too much. Oh, it's symmetric, 300 up, 300 down, and capacity is 3.2 terabyte, the bandwidth. So we adapted these much faster, but we have to upgrade our farming. We need food far more than we need internet or 5G or wireless. So fundamentally, we really need to upgrade. Now again, let us be very clear. I'm talking about these 3 tools. Every country, every government that has some level of competency is working on it, trying to get the farmers to change. But farmers are way too hesitant, and there is a penalty to it. The longer you wait, the worse it will be for you. Basically, if you start today, it may take 3 years. You start tomorrow, it will take 4 years. And it does take few years for the ecology to actually grow naturally. And then once you can hold on to that period, that brutal, painful period of first few years, then it starts to yield. It's almost like mutual fund investment. Slowly. And over time, it's like, I got you, fam. So how much I got you, fam? So farmers who have done this for 10 years, yeah, they do not know about fertilizer anymore. They do not even know the fertilizer price. They don't need it. Again, once the ecology is there, once you have enough what you call diversity, nature is like, I got this. You do not have to got this. It's like nature is like, I got this. Rain happens, brutal rain happens. Like, bro, I got this. Don't worry about it. So that's what we have to do. Basically, the same ferocity we did for fiber, internet, and 5G, we have to do the same thing. Basically, if we do short-term crop cycling that we are doing right now, dead soil. Soil dead, we dead. So farming, this is really stupid given the fact that how quickly we adopted other things. Like, we really need this. Like, TikTok should not be that popular compared to this sort of healthy soil farming. Then we come to another pain point for me is biofuel. Now, biofuel is basically, think in this way, humanity is right now crying that we are dealing with global warming. We should not have. That's the tragic part. We should not have. Like, our starting was perfect. Like, we started exactly how we should have done. So our starting was perfect. Basically, we were running on biofuels on day one, and biofuel does not add CO2; it just cycles it. Meaning, you burn fuel, your engine goes whoom, so you have boatload of CO2 coming out. What happens to that? The next crop cycle eats it up. And how does it? The energy comes from? It comes from sun. It's basically solar energy converted into chemical energy, but rather than like my solar panels converting solar energy into electrical potential. So solar to electric, we know how to do it. What biofuel is? Solar to chemical energy. So that's how you keep cycling. You can keep burning as much fuel as you want. As long as it's a biofuel done properly, you do not have to worry about it. You do not even have to think about it. It does not matter because it's a cycling thing. It's a cyclical structure. You do not have to worry about it. And basically it's running all your infrastructure on solar power, and it has less metals, meaning once we actually extract crude oils from deep wells, we have poisoning things into that, like mercury, basically things you do not want into your airstream, but it does come into your airstream simply because some things are added, some things are basically ground contamination, which we cannot remove. Again, we can remove it, it's just exponentially more expensive. So what if you had a fuel that was not contaminated by those mercury and arsenic and things of heavy natures? Wouldn't that be better? So that's possible. That's how we started. Now, what does that mean? That's how we started. You must know that after steam engine, the biggest engine innovation that happened was Rudolf Diesel's diesel engine. Yes, the engine's name is after his honor. It's not like he called himself Rudolf Diesel. He's not Vin Diesel. So Rudolf Diesel was the individual who invented diesel engine. Now here's the deal. There was no diesel fuel at that point in time. Yes, crude oil was being distilled, but diesel was let out because again, people did try to burn it, but that only burns in extreme temperature or extreme compression. It was not very easy to use, so it was a byproduct. And yes, you heard it right, diesel was a byproduct. Nobody knew what to do with it. But that happened very later. So how did, in the meantime, he was running his engines? Vegetable oil. If you ever watched any preppers video or like people talking about like, we can just run diesel engine on basically oils. That's the reason. That's how it was designed. That's why it has such a high compression. It's built for it. You can take a basically unmodified basically diesel engine right now. It's like, I got this. You can feed it filtered. Basically, you do not want contaminants. Basically, you do not want food particles there. As long as you can filter it reasonably enough, which you can do in your garage, voila. And again, people have been doing it for decades. We started with that. Like, think about it, like how thoughtful we were, how lucky we were that our innovators were like, bro, I got this. Like coal power plants, yeah, they had the issue. We were starting to, go back into the Earth's reserve and pull out its poop. Basically, it's carbon material, heavy carbon material like coal, crude oil, natural gas. These are heavy poop, which nature is trying to submerge away. It's like, let's let the poop be there. Let's not pull out the poop. So what we did, we pull out the poop. Now here's that's the first massive use of steam locomotives. What is the next big thing? Diesel locomotive. What is running on? Should have been running on vegetable oil. We literally went from, we could have almost fixed the humanity. And this is, be mindful, this is late 1800s. And then you have the granddaddy of basically automobile. That's Henry Ford. Back in that day, as in like 1908 kind of day, he figured out ethanol would be a good tool. Again, he was also on the right track. It's like, hey, what if we grow the crop to consume the fuel? So rather than relying on OPEC, again, that time it was not called OPEC, but relying on other people, we can just grow our own. We can be efficient. We can be self-sufficient. India is not truly independent if we have to call other people to get our fuel supply. Because again, without fuel, we do not have agriculture. Without agriculture, we do not have food. We did. So fundamentally, having that is a very crucial requirement. All these two people, which has the significant, most boomers impact on our civilization, they were on the right track. Now, here's the deal. So far, you were like, okay, but it was not really the right track. Yes, absolutely. So those were in the, like, basically they threw in the right direction, but like did not land it. Then we had Aquatic Species Program, ASP. Now, back in the days of like, Soviet Union era and after the World War II and in the Apollo era, America used to have brains. I do not know where it went, but they used to have brains. So oil embargo happens. Basically, Arab, Israel, boom, boom happened and bad things happened. So a project was created, Aquatic Species Program, ASP. The project's idea was very simple. Give USA independence, meaning they should not be dependent on, and that's why I said like it's mind-boggling that they had brains back then. It's in 1970s, project was created, greenlit, funding was done from federal government. Now the project was concluded, meaning they closed the book in 1996. And I'm like, okay, so it was a quite long run project. What did they got out of it? They got microalgae. What does that mean? That simply means this, puppy. So they were so smart. Again, they did it thoroughly, scientifically, everything. So these people, they were very on the right track. Basically, Rudolf Diesel and Henry Ford, they were on the right track. We have to run on biofuel. But they cannot grow crops. You cannot grow ethanol on land. You will die if you do that. Yes, that means America and Brazil is going to suffer brutally for this. You need proof for it. Look into their, again, America recently published a result for it. It's like, what was this experiment of great ethanol experiment? Consequence was like, yeah, they are creating far more CO2 pollutants than they are actually removing. And again, Brazil is also suffering from the same consequences. Again, you can read that research. It does not work. You cannot touch land, which they figured out. Again, it's a long-term research project. So they were very thorough. The reason is microalgae does not compete with the food crops for land. Meaning, if I asked you, like India needs to run so many jets, we require a jet propellant one. How much jet propellant one? You will get X amount. Let's just say that X amount requires 100 square kilometers to grow. Now, is there anything better that can shrink that number? Yes, algae. You must know, algae is the highest yield we can do. Yield of lipids. Lipids is converted into heavy hydrocarbons that we utilize. Okay, then why don't we use algae? Everybody who did that, which mind you, I have no idea how the heck Reliance fell for it. Reliance is India's largest, one of the largest. I'm not sure it's the only largest or one of the largest is oil refinery. They were like, okay, we are experimenting with algae biofuel. I'm like, what are you smoking? Algae requires fresh water. We do not have that much fresh water. Nobody has that much fresh water. It takes almost 600 to 400 liters per liter of fuel. Yeah, you're not using that. You're not using. Yeah, it takes less surface area, but you do not have that much water. You just don't. So in this species program, they figured out salt water. What is we have infinite of? Ocean. What do we have infinite surface area of? Like infinite of, I'm being facetious, but you get the point. Like if I ask you 100 square kilometer for India to give, they cannot give you on anywhere on the land unbroken. I ask you that much in sea border, it's like, bro, that does not even touch international waters. Like, bro, we got this, we good. So that's why this is figured out. They're done. They sorted. 1996, all the research is done. Research is available for public. Food crop, you will not touch the food crop. So crop cycling can go on. You do not have to worry. You do not have to put fuel crops. And again, you can scale it because again, 10,000 square kilometer is a barely inconvenience on the ocean floor. And be mindful, if we do not change it, we will cook the whole planet. That will destroy everything. So I rather choose 10,000 square kilometer area. So that's what does. Now here's the deal. This is another benefit of this technology. This is what we should have done. And what is the benefit of this? This is trapping CO2. So you're taking CO2, you're converting it into hydrocarbon. Okay, what can we do with that? You can keep overproducing it. Meaning, let's say India takes 100 square kilometer to get the fuel out of it. Okay, so we farm 200 square kilometers. Like, why? Here's the deal. All that hydrocarbon, you cook it. You make it as heavy hydrocarbon as possible. Or you don't even have to do it. It's not necessary. But you can take that liquid hydrocarbon, you pour it back into the ground. Basically, all the oil wells, you turn the oil wells into oil pumps and you just pump the oil down. Forget about it. Basically, we are undoing what we did. All we have to undo, press Control Z. We are pressing Control. If you have done long works, you're like Control Z, that's what we are doing. So everybody's like, what if we destroy a mountain? What if we get the limestones out of it? What if we did this? Like, what if you don't? What if you did the logical thing that nature did in order to trap all the CO2? You did seaweed biofuel. All the research paper is available. That's why I said, like, it's in 1996. Now, like, okay, if it was that ahead, why the heck it stopped? Again, America lost brain. And during this time, somebody in OPEC was smart. And I'm like, whoa, smart. As in, like, smart enough to read papers. And what does that mean? That simply means somebody figured out if we do not let this project die right now, they will start the project. If project starts, as in like large-scale industrial production test. If that starts, over time, the price will come down. Over time, it will become efficient. That means we'll get price locked. And if we increase our price, they will increase their production and then we'll be competed out on us. So at that point, exactly at that point, 1996, look into what happened to oil prices. Not exactly, it's not precise. Like this month, the paper came out as like somebody knew, but let them be very clear. Somebody knew that how the math works, supply demand works, and they're like, hey. So this research paper, when it was closed, like how much is going to cost, right? That's the whole point. So the estimate was the at best case scenario is going to be 2x the fuel barrel price. Meaning fuel barrel was $15, let's say, $15 per barrel. You're going to be expecting 30 per barrel. Now, if like, wait a minute. That was in 1996. What does that mean? That simply means America was stupid. Because if they had continued that research, and again, let that be very clear, I'm assuming they are full of shit and assume that price is at least 3x more or even 4x more, it still would not have been a gold mine. Why? It grows, it expands. Every tool you build, you refine it, you improve it, it goes down. Again, oil well is a fixed unit. It's done. So oil gets harder to extract while this becomes easier to expand. And we did this with solar, we did this with wind. Go 15 years ago and tell like a version of me that the solar panel that I have 2 kilowatt solar panel and it was a minor inconvenience. Like again, my problem is like, I actually want like, whole house to be solar, that requires 10 kW, but I already have 2 kW. It was not that expensive. The panels we have right now and deployed in the field, the efficiency that we have, if you have talked about this in like, Jimmy Carter era, people are like, what the hell? You're talking about, I think selenium solar panels were being built at that time. It was 1% efficient. We are at 15 right now. Same thing would happen this. Like, yeah, first time the mining would be clunky, the instruments will not work, the refining process will not be. Again, you'll keep working at it, you keep polishing it. Exactly how we did solar, wind turbines and solar panels, and voila, you would have a complete supply. And be mindful, even if it was 5x the price, it still would be cheaper. And be mindful, that would be a price cap, meaning OPEC can never increase the price beyond that point, because again, governments might be just like, yeah, let's just again, if the price is too close to each other, government might just decide, hey, might as well boost it, give it some subsidies. Again, we did this with solar and wind. It's just like we become independent. We no longer have to listen to Venezuela. Again, that's why I said like they used to be smart. Again, either somebody was way too smart in OPEC communities, or somebody was too dumb in America. I will go with too dumb in America. Because again, they were this close. Humanity was this close to solving this fuel problem before it became an unsolvable mess. We had that. And again, it's a dual prong attack. You get a fuel that works on all your system right now, and you can keep increasing it, and you can sequester the CO2 without any issue. And again, you can even sell it to public. It's like, hey, this is an emergency reserve. Which again, it is an emergency reserve. Although it will go in clean but come out contaminated with mercury and all the heavy metals on the ground. So that's the side effect. And again, all this paper is available, all the research material is there. There is nothing on this planet Earth that can provide the energy density of a hydrocarbon fuel. Nothing is even close. I'll explain all the other bullshit we have done, but flat out nothing else. Again, we have flown jumbo jets on it and no modification was needed, because if you need modification, that means the filtering stage was not done properly. But other than that, nothing. Planes have, that's why I have only noticed pilots are the only smart one who can say like, dude, you cannot run planes on liquid hydrogen. We have tried, we have done it. It does not have that necessity. I'll explain that further. And we have flown on healthy fuels. Oh, somebody actually did that. Basically take a cooking oil and made it into jet fuel. Yes, that has been done. And yes, the plane has flown. And yes, it's a normal thing. So that's the biggest stupidity. We were so right on the track, like Rudolf Diesel is like, I almost got you there. Henry Ford is like, I almost got you there. And all the engineer who worked in ASFP program is like, bro, I gave you the answer. And we are like, but what if we did ammonia? What if we did sulfur? What if we did sodium? And what if we did hulu? It's like, what if you did what nature did? Control Z on the nature. We had it, past tense. So we come to the hydrogen bullshit. So here's the, let this be very clear. There are many industries, too many to count, that needs hydrogen. So if we have clean hydrogen source, rather than taking natural gas and steam reforming it into and having the poison of CO2 and basically hydrogen, which again, you're basically burning methane at that point in time, it's just indirectly. If we can get a clean H2O source, that's priceless. What fields do we need it? Food industry, lot of oil processing and fat processing requires hydrogen. Like it's not optional, it's compulsory. Then you have ammonia production, methanol production, then you have metal refining. There are fields without hydrogen supply, it does not work. So let that be very clear. We need hydrogen. Having a clean source of hydrogen for these sort of sectors is priceless. Shut up, take money, give your nation independence. Good, GG. So what's the problem? Well, we kind of started smoking weed when we are like, okay, we forgot that where hydrogen is on the periodic table. Where the heck is hydrogen on the periodic table? It's the first element, it's the lightest, it's lighter than air. I'll explain what does that mean. So it's great for all these processes. We use it, it's awesome. We need a clean source for it, awesome. But it's useless as energy carrier, meaning if you have to, I give you energy, right? I give you 10 megawatt hour. I give you 10 megawatt hour. How can you carry it from A to B? Hydrogen is worst for that. Like worst. Like there is no competition that versus batteries. You literally will get more distance covered using your battery system compared to hydrogen system. Oh, and again, if somebody is like, oh, hydrogen can refuel quickly, that's a genuine mathematical benefit you have. You can refill it quickly. It's just that Chinese people and Indian people, both of them have brains, and they realize, hey, what if we swipe the batteries? And yes, I'm talking about trucks. Yes, it does require a structure where they have a truck going in, almost like a weighing station, have a small crane. Again, fine-tuned, it's like a cable-based crane. It just pulls out the new battery, puts a charged battery. Everything in battery is charged very slowly, very controlled environment, no big issue, minor inconvenience. Instead of like going whoosh, you just go tweet, tweet. That's today. No, and be mindful. You're like, oh, wouldn't that be expensive? Compared to hydrogen, it would be free. It is free. Compare the hydrogen bus prices, compare that hydrogen bus prices to electric bus prices. It's 3x difference. And I'm talking about the bus. I'm not even going into price of charging infrastructure and all that swapping mechanism. That's free compared to compressed hydrogen storage tanks. So yeah, we've been there, done that. That's the stupid part of it. It's useless as energy carrier. Why? Again, conversion steps are too much. If I give battery, what does it store? Takes the electrical impulses, converts it into chemical bonds, and undoes it. Doing. Very simple. Energy, electrical into chemical, chemical to electrical, done. What happens with hydrogen? You may say it's the same thing, but it has so many steps. Basically, you take water, you basically run electricity through it, you get hydrogen gas and oxygen gas. Here's it, you basically turned liquid into gas. That's a phase change. It takes energy. You're like, yeah, it takes energy. Yeah, that also means oxygen is taking some energy away that you cannot recover. So hydrogen, now you store it. Now you have to compress the hell out of it. You have to compress it to, let's say, low cost 350 bar, high cost 700 bar, or stupid cost liquid hydrogen. You have to do, again, this will take energy. Then you have to compress it, store it, do whatever you have to do. Then you put it into your vehicle. Okay, cool, got it. After that vehicle, you have to do the same thing again. You take the hydrogen, react it with atmospheric oxygen, and then you get water. But here's you. How is that water coming out? That water is literally in water vapor format. It's gas. It takes some energy away. That's why conversion efficiency from hydrogen to electricity is not as efficient as basically battery system. It cannot be, because again, oxygen, you have water vapor coming out of it. Again, some water will trickle out because it's not very, very hot. It is hot. Again, hydrogen trains, you will see there's giant stacks of steam coming out of it. That's where it's coming from. So not giant, but you pay attention to all the photos and you will find some photos, especially in some weather conditions, it's like very obvious that that's what's coming out. So you get, basically, if you put 100 units of electricity in real world scenario, you're gonna get 50 units out of it. In most efficient scenario, which is like scientists worked on it, like really refined it, let's not talk about the price, let's just get the efficiency down. Yeah, you would be lucky to get 70 out of it. Battery system, if you put that kind of money, you get 100 out of it, almost 100. Like 95 is normal nowadays. So that's the whole point. Swappable batteries will bitch slap hydrogen system on cost and basically efficiency. And if you're like, oh, we can get hydrogen from solar, it's like solar panels are not free. Solar infrastructure is not free. It's not free. You have to make that solar panel, you have to maintain it. And again, trust me, I installed it recently. It is expensive. Panel, not the panels, it's just the inverter needed, wiring needed, all of those things pile up. If you can get the work done in 10 megawatt, why would you want to pay 23 megawatt? If you can get the work done in 10 megawatt hour, why would you want to buy 23 megawatt? It's like stupid. Just do with electric system. Again, that comes back to the same point. It does not have the density. Now you'll be like, what, we cannot fly planes, jumbo jets specifically on batteries? Absolutely. So that's why I said that. That's why I'm so angry that we had the solution, biofuel, but here. Now, the people who say that you can run planes on hydrogen, there are two types of people. First, who do not do math. Second, who do not study history. Or there is a third type, but I do not blame them. They are forced to do it because government passes stupid laws. And yes, that has happened in history, and that is happening right now in EU. By 2050, they are banning hydrocarbons somehow. So what do you need to do in terms of math? Well, you have to know the difference between 8 and 30 plus. What does that mean? This is from Department of Defense and this is from Department of Energy. You can find it, and be mindful, this is a very common graph available in all encyclopedias, all science textbook, and this is one of the few common things that people do. It's very common in terms of chemistry to calculate the energy density. So you have galvanometric density. This is how people give you the seaweed, bad quality weed. So they will tell you hydrogen has 3 times the power of gasoline. Oh yeah. 120 megajoule per kilogram. That's factually true. Compare that to gasoline and diesel. That puppy barely touches 40-50. So exponentially higher energy density. That's true. That's awesome. It's just that once you do to volumetric density, not even volumetric, basically galvanometric density. Volumetric, yeah, we are talking about volume. Volumetric density, it falls apart. What does that mean? That simply means you have to carry the damn thing, right? If you have a plane or train or truck or whatever have you, it has a tank space. How much space it has for the fuel. Now we come to the real part. So if I give you diesel, that gives you around 35 almost megajoule per liter, meaning I give you 1 liter tank capacity. How much you can store? 32. So how much hydrogen gives you? Liquid hydrogen, the best we can get, it's around 8 to 10. Actually, it's 8. I think they are very sloppy. It's 8. It's very low. What does that mean? That simply means if your engine, diesel engine is efficient, this cannot compete. Liquid hydrogen cannot compete. If you come to real world where we are using 700 bars of hydrogen, yeah, we are not competing. That's competing around 5 megajoule per liter versus 32 megajoule per liter. You cannot compare. Now, be mindful, during the same era of SR-71 being built and basically Soviet Union and all that, there was a lot of interest in basically hydrogen fighter jets. The reason for that is that time jet engines were new. World War II was over, jet engine being researched, it was very new, it was very inefficient. So we knew that jet propellant 8 was very energy dense, but engines were not getting most out of it. Engines were here. So you must have heard this, like the old power plants, very old power plants, like Thomas Edison's times coal power plant, they were barely 1 to 2% efficient. That was happening with jet engine also. We had jet engines, it was flying, but it was not very efficient. So that time people tried with hydrogen, and because of the hydrogen's nature, it was very easy to get almost like 50-60% efficient of hydrogen. Now be mindful, because of so much inefficiency in hydrocarbon system, people were like, hey, hydrogen is the future. This is the same time jumbo jets were being built with liquid hydrogen. Yes, it was built, and Tu-144, I think that's the name. Soviet Union built it, flew it, and it was useless. America built a fighter jet and flew it, and it was useless. And all other companies, all other countries, everybody worked their ass off, and outcome was the same. The moment basically jet propellant engines became efficient, basically the burner design became efficient enough, and the compression became high enough, the temperatures become high enough, the energy efficiency starts to reach slowly crossed here. What does that mean? That simply means you have to be 160% of hydrogen in order to even compare. So right now you take Airbus A380 and you're like, what if I swap the engine with magic engines that are 100% efficient with hydrogen? Here's the deal. Take Airbus A380, convert its kiloliter capacity of basically jet fuel to hydrogen somehow, rather than a cylindrical, well-insulated tank. Somehow you magically convert it. You will still have less energy. That's the whole point. You have to have megajoule per liter. We know this. We have known this from 1920s. People thought of it. People built it. We studied this. Outcome was the same. You will not have the payload capacity. You will not have the range. You will not have the speed. You have to reduce all three. At that point is what's the point. Go with the biodiesel. So that's the whole point. We have done this. Like, this is not new thing. This is like, oh, hydrogen will be the future. Like, we've been there. Like, this is 70s. And that's why I said only two people are basically going about hydrogen. A, who do not do math, basically understanding this graph, and another who did not study the history. Again, all the papers are available. You can look into it. From Air Force to NASA to every Tom, Dick and Harry did the research on it. Outcome was the same. It does not have the oomph needed. And again, even Germany did hydrogen train, and they were like, yeah, it actually would be cheaper for us to just have battery. I'm like, it would be so much cheaper if we just had third rail. It's like, we've been there. Like, this is not a new thing. It's like, been there, done that. Most people don't even know that we have done that. That's why, like, oh, hydrogen is the future. It's like everybody who says that hydrogen, they are buying this part, megajoule per kilogram, which is factually true. It's just that, bro, you need to figure out megajoule per liter, not kilogram, because hydrogen is the lightest element. Without carbon binding, it is useless. That's why I've seen at least more than few pilots who are talking like, yeah, hydrogen won't work, because again, they deal with this calculation. They're like, yeah, bro, you do not. Again, you assume any efficiency above 23%, you are reaching a point where hydrogen cannot compete. And our diesel locomotives, our diesel engine used in vehicles, they are above that. We are touching 30%. And there are new designs that could cross 35%. There are F1 engines that are 51% efficient. There is no competition. We crossed this. Like, the highest you can do, we have crossed it. Like liquid, you know, why are you comparing with liquid? We're going to compress it. Like, compress is less. Solid, liquid, gas. There is only one way where you can have enough density. That is solid metal hydride. Now, like, okay, then why don't we use that? Did you not hear? Solid metal hydride. What does that mean? It's a metal powder. You are storing hydrogen in the metal. Again, you can exceed this basically volumetric megajoule per liter. You can exceed that. Consequence is, it's 10% by mass. As in, 100 kilogram tank, weight wise, will only have 10 kilograms of hydrogen. It will be small, but it would be basically a cylinder filled with metal, heavy metal. So yeah, you cannot fly planes with that. You can do submarines with it. And again, Germany has a submarine for it. And again, Sweden also, if I'm not mistaken, they are also working on that. So anybody who knows the difference between 8 and 30 knows this. Anybody who studied history knows this. We've been there, done this, tried this. It will not work. Again, the EU members who are like, we're going to ban hydrocarbons. Like, have you ever studied? No. It's like people are like, what if we use ammonia? It's like, it's poisonous, my man. It's literally poison. Oh, and it also has less capacity. Hydrogen, man. Look into Airbus A380's hydrogen transit conversion they are doing. They have giant liquid hydrogen tank on the back, 4 of them. And there is tiny engine, passport size engine. It's from a business jet engine. And when I showed you about biodiesel, it was on the main engine. Why they are running on a liquid, tiny engine? Yeah, if they had fed hydrogen into the main engine, it's gonna be like, done, sir. Before the runway you take off, it will run out of fuel. We have been there. Like, that's why I said, like, to pull off TU-144, we've been there, done that. We know what is the outcome. And again, in India, in today's global warming, it's like, yeah, plane goes into tarmac and fuel is like, nope, I'm out. Be mindful, liquid hydrogen is almost at 0 degrees Kelvin, while compared to our atmospheric temperature, which is like 45 to 50 degrees Celsius. Yeah, it's not gonna last. So that's the whole point. You can achieve all the vehicle things that you are talking about. You can achieve with battery swapping. Again, jet will not work with either battery or hydrogen. We've been there, done that. You require biofuel for it. And that's the whole point. The core mistake is people converting the megajoule kilogram to megajoule per liter. Anybody who says that, oh, it's more energy dense, take your sleeper and heat them with it. Again, every university has this. Now we come to another stupid part that we truly fail to utilize is biogas. Now, we have a huge source of carbon neutral fuel. And again, these fuels would be awesome for heavy loads and storage also. Every Tom Dick is like, we need storage, we need storage. What's the best thing to store? Fuel. So you can store it. And be mindful in terms of electrical energy. How will you store that much electrical? If you have a giant, basically biogas system, all the jet engine plants that we have right now, most of them are running on basically, rather than kerosene, most of them are running on natural gas. And here's what's the difference between natural gas and biogas? Answer, nothing. Nothing. If the refining stage is done correctly, let that be very clear. CH4 is CH4. If you're talking about contamination, we are actually talking about the difference between them. So some may have sulfur, some may have a bit more mercury. That's up to you. Again, it's up to you in terms of filtering stage, how much you want to purify. So that can take care of heavy loads, trucks and all that, exactly like how it is, not super expensive. And again, India already has the infrastructure for it, and we can even store it for long term. Now, why do we have to do this? Well, here's the horrifying part. CO2 is a bad gas. Why it's a bad gas? Not it's a bad gas, it's like it's becoming bad gas. It's the same thing. Little bit of blood donation, everybody wins. Too much blood, you dead. Same thing with CO2. Sun is a nuclear reactor. It's a fusion reactor. It's GG. It's a basically giant incandescent bulb which has a giant spectrum, wide body emitter. So it emits ultraviolet, infrared, optical. It just roasts the earth. Now, GG amounts of energy comes to us thanks to inverse square law, and because of the fact that we are 8 light minutes away, enough energy does not land on us, so we heat up. Now, here's it's still too much. So what happens? We spin. So what happens after that? Well, we go to the vacuum. Basically, we go from the sun putting energy into to vacuum space, that is vacuum, void. Energy goes from high to low. So the surface that is hot now wants to dump the energy. Now, how does Earth dump energy? Everything emits infrared glow. So we glow in IR spectrum and energy goes into basically all the photons goes into space, and we do not have to worry about Earth's temperature cool. Now, CO2 is a throttle gas into that. Basically, how much IR goes up. Basically, our IR transparency, for a lack of a better term, our IR transparency is not absolutely zero. It's not like everything goes out. Again, we will freeze to death at night if that was true. But we have enough of it where it's like some amount comes back. So we have enough turbulence, enough atmosphere, enough insulation. All of these things are working perfectly to create perfect planet known as Earth. We messed up the CO2 balance. Basically, CO2 is far more opaque now than it used to be. Consequence, too much heat stays in. So that effect, too much heat staying in, we call it global warming potential, GWP. Now, CO2, again, that's our main gas. So we classified it as 1. CO2 is 1 gas. Basically, CO2 has a damage of 1 CO2. So what is the damage of methane, CH4, that comes out of your back? That's 80x when you are talking about 20-year time period, because after that, majority of it will be broken down into oxygen and carbon. Basically, it will burn. It will oxidize, so to say. But in the first launch, basically, let's say, so much CH4 went out. 80 times more harmful, meaning it will roast the planet very quickly, and then it decays, and then also it remains 20x more potent for 100 years before it even flares out. But again, we will not live that long if this CH4 is not removed from the atmosphere. And that's why all the biogas refineries and all the places where you have CH4 in natural gas also, they have a flare stack. It's required by the law that if you have a scenario where CH4 is being released in the atmosphere, set it on fire. CO2 is far more gentle compared to CH4. So we have to do this. This is almost like how cities have giant budget for garbage collection and all that, because we have to do it. It's not profitable. It has to be done. So same thing, we have to do it. Basically, we have to think in, we have to burn it as insurance policy, right? So same thing we have to apply here. It's like all the human poop, if collected properly, like again, you have to figure it out how you have to build the infrastructure for it. All the things I have to milk for it in order to capture the CH4 emission. Now here's like, would it be enough? No. That's why I said like it does not have the economic benefit, but we have to do it as a insurance policy. And what will we do with that CH4? Here's the deal. We have to burn it. That's the least destructive option for us. Voila, we have a lot of ways to burn it. Oh, and this is another detail that is now being talked about in shipping industry. It's like, how the heck you're going to move your ship, right? It requires fuel tanks, and fuel tanks cannot be larger or even same size as the cargo itself. So if you take LNG, right, how much oomph you need? So this is one. LNG is one. That's the base unit right now. So what will the size requirement grow if you want to carry the same amount of energy? Let's say this has X amount of energy and you want to achieve the same amount of energy. How much ammonia you have to carry? 1.9x. Bad, but not too bad. It's almost like 2x, but not too bad. What about hydrogen? If you want to carry the same amount of oomph, 2.5x liquid hydrogen. That's why I said it's fun. And be mindful, because they are comparing with LNG, that's why it's at least in the same ballpark. If they were comparing this puppy to heavy oil or bunker oil as they call it, yeah, good luck. This will be huge. So that's the reality. At least shipping industry and airline industry, these are two industries where people who are working on it, they know hydrogen does not work. Ammonia, at least they're like 2x, so we can push it maybe. So that's the, be mindful, we need hydrogen for industry, but as an energy carrier, that's the problem. Your ship will become tiny. So we have to burn it as a system. And again, think of it this way. How do you sell it to public? Again, we are reducing waste. Everybody can get onto it. On top of that, we are getting free fertilizer. Most bioreaction systems gives you a biofertilizer, which is really good, really healthy, will help our farming steps, and it will help the crop cycle. And again, we are burning CO2. No, it's carbon cycle. It will be released into the atmosphere one way or the another. Releasing it in a less potent form is a really good thing. And again, it will be consumed in the next cycle. So it's a carbon neutral system. Again, it will be more of like, you have to spend X amount of money. By selling the CO2, CH4, you can reduce the cost from X minus whatever percentage, 30% less, 50% less, 70% less. As we do it on larger and larger scale, we'll get more efficient. Maybe, just maybe we reach break-even point where it's like, hey, we are almost paying nothing for it. So that's the another part. Like, we should have done that. We have not done it yet. So these are a few of the biggest stupidity humanity have done so far that has basically led us to current mess as of now, right now. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.